Hey guys, this is Algebra 2. I wanted to talk a little bit about the homework and kind of what we did today in class. Today's lesson was about end behavior and how to find zeros, and also we almost got to relative minimum or maximum, but that was something that we talked about as well. So we kind of talked about this notation for how to describe end behavior, and there's a part of your answer that's always the same. As x approaches negative infinity, that represents going left. And also, as x approaches positive infinity, that's as the graph moves right. So the other part is what happens overall, is it going up or down? And so we went ahead and sketched in class this idea of x to the fifth, and it's positive. So what this is saying is as x moves more left, the graph's going down, and as the graph moves more right, the graph goes up. And so we have this way of talking about that with end behavior notation. As x goes more to the left or approaches negative infinity, the output goes towards negative infinity, which represents this part going down. And as you're talking about x going towards positive infinity, well, the output goes towards positive infinity, and that's what we see on the right. It's going up forever. So let's kind of look at a few different examples here, and I hope you're getting better at the whole idea of sketching these based on the leading coefficient and its degree. So this is a positive even, which is x to the fourth. So this facing up overall. And that's what this other part is representing. As x moves left, the output goes up forever. As the x moves right, the output goes up forever. I hope number 5 is a little easier because that's a quadratic. We've been talking about those a lot. As it's facing up, and so again, that first part's always the same. As x approaches negative infinity, that means as the graph moves more left, the output goes to positive infinity. As x approaches positive infinity, that means you're going more right. The output goes up forever and ever and ever, approaching positive infinity. So take a look at these, and we'll talk about these in class tomorrow. Let's look at some of the stuff that we did for finding roots. So we talked about finding roots today out of factored form, and so each of these are factored pairs. And so once you understand that you can set them equal to 0 and solve for what makes them 0, then understanding how they sketch is a lot easier because you understand that that's where they hit the x-axis. So I think I did this one after school, and that way I didn't have to write or type into the laptop here. So we took each of these parts, x plus 5, 3x squared minus 4, and x squared plus 3, and set them all equal to 0, and we try to solve to see what makes them equal 0. So this first one has a two-step solve, and you end up getting negative 2.5 or negative 5 halves. The second one you end up getting two solutions from, because when you square root this, you end up getting a positive and a negative of that value. And then the last one, we talked about how when you have to subtract and then square root, it produces a negative. And so that negative can be taken care of by putting an I out front, which represents an imaginary value. So I want you to try these on your own, and we'll talk about those in class. And just set each part equal to 0 and solve. This one should have 1, 2, 3, 4, 5 solutions. This one should have 1, 2, 3, 4. Last thing I assigned is to talk about how to write the equation of a polynomial if you knew the zeros. And it does say standard form. We'll talk about how to get that out of factored form and into standard form tomorrow. But today I just wanted us to kind of talk about these problems moving in the opposite direction, as if you already knew the zeros and you're trying to build the factor pairs. So number 19 says write the equation of a polynomial in standard form with the zeros of negative 1, 5, and positive I. So this negative 1, we need to write a factor pair that makes that equal 0. And so if we had x plus 1, that would make it 0 when you plug negative 1 in. Similarly, if you had 5, you would need x minus 5. 5 minus 5 is 0. And then this last one is x squared plus 1 because we need I, and really technically negative I as well. They always come in what's called conjugate pairs. Conjugate pairs means that you always have plus or minus of that idea. And so we need that to be x squared plus 1, so that if you set it equal to 0 and you subtract 1 over, you're square rooting a negative 1, and that makes it imaginary. So I want you to try 20 in that same kind of fashion. Write the factor pairs for these 3 ideas, and we'll check your work tomorrow. Have a good night, and I hope this video was helpful.